Always it's my pleasure to talk about GD&T, one of my favorite topic. GD&T is a vast area. You may require a lot of time to understand the entire. Let us try to understand the basics of the GD&T. Objectives of today's program. I will talk about introduction to GD&T, understand the need for GD&T and GD&T standard. Since all of you know about GD&T symbols, we'll little discuss about GD&T symbols. Understand advantages of geometrical tolerancing over coordinating tolerancing. How implementing GD&T will lead to cost reduction in a broad perspective. Let us look into it. Geometrical tolerancing is called GD&T, right? Geometrical dimensioning and tolerancing. What is GD&T? Geometrical dimensioning and tolerancing is an international language today that is used on engineering drawing to accurately describe the part. We are all engineers. We all communicate through the drawing. The drawing, if you want to have what designer think as a concept, you want the same manufacturing guy has to think, then all the information it is there in the mind of a design engineer should be transferred onto the sheet of paper. If some shaft not to be bent, I have to tell it should not bend beyond this point. Or one surface is perpendicular to the other surface, we should be able to tell, right, this should be perpendicular within the specified values. These are all need to be put on the drawing sheet so that the functionality, in the function, it performs better. Hence, this GD&T is an international language today. We have international standards for GD&T, and this, based on the international standard, if you use it on a drawing sheet, right, you will communicate in a better way so that what designer thinks, what manufacturing guy understand, it will be the same. Hence, it is called international language. What is GD&T language? International standards. It is consists of set of symbols. There are about 14 symbols in that. Now it is about 12 symbols as per the latest standards of 2018. There are many rules, GD&T rules. There are many definitions and conventions. We need to understand all these things so that you can, when GD&T information is there on a drawing sheet, you will be able to understand better, right? You should know how to interpret when particular symbol is used, how to apply the rule, as per definition what, you should be able to interpret. That is the difference between what is called as a conventional plus minus tolerancing and GD. GD&T required lot of interpretation knowledge. If you want to have a lot of interpretation knowledge, you should have thorough understanding of rules of GD&T, definitions of GD&T, and conventions of GD&T. It's a precise mathematical language that can be used to describe form, orientation, and location of the far future, right? GD&T is meant to control the form, control the orientation, and control the locations of that. Let us understand when you move forward. GD&T is an exact language that enables designer to say what they mean through the drawing. That means he, as a design engineer, it's an excellent design tool. What is their concept in his minds of a design engineer? When you want to put those concepts on a sheet of paper, that GD&T tools is going to help him to transfer all the concept onto the sheet of paper. That is what is the beauty of a GD&T system, that will help him to bring all the concept onto the sheet of paper. GD&T is a design philosophy. GD&T is also called functional dimensioning and tolerancing. The reason is GD&T understand the functional requirement. Let us two parts are assembled. when you ask it to understand the functional requirement, accordingly vary the tolerance. Look at this. In a conventional systems of a plus minus tolerance, once the tolerance is given, it is fixed. But in a GD&T, according to the functional requirement, it can vary the tolerance. Hence, it is also called functional tolerancing. It understands the functional requirement in a much better way, and accordingly it will vary the tolerance to make manufacturing easier. Hence, it is also called functional dimensioning and tolerancing. What is the need of GD&T? Let us understand why we required GD&T. Let us use some drawings here to understand the need of GD&T. Let us take this drawing. It is a cover. It's actually one part. This is the entire, all the dimensions are given here, right? It is a part to be manufactured. Let us say this drawing is given to the some vendor for manufacturing. Identified vendor, I'll give this part to him. He should be able to manufacture this because all dimensions are given here with the tolerance, right? All the dimensions are in inches, right? Many dimensions are there, 7 plus minus 0.02, many such dimension. Using this dimension, vendor will be able to manufacture this part. Let us assume this drawing is given to the vendor. This vendor will go through the drawing. Let us say he quotes, right? Let us say he quotes close to rough figures about $500 for this particular parts. Let us take it. He go through this, understand all the requirement, and let us say quote about $500. Let us finally, we gone through the drawing and he studies that and manufacture the part. Finally, the part comes out like this. I hope we could able to see this. The parts, look at this part. This part, as per the dimension, it is perfect. No problems at all. I am putting the other original drawing also here for your understanding better. Take any dimension here. All the dimensions are within the specified tolerances. But still, looking at the part itself, I can say this part cannot be usable. We have to reject it. I hope everybody understands why we have to reject it. This particular face is not flat at all. Supposed to be flat as per the original dimension, but it's not specified anywhere. But it's not flat. Since it's not specified, I can't demand from the vendor. And this particular hole or the bore is not concentric with an axis. It is not concentric at all. This surface supposed to be flat, required for an assembly. It is not flat at all, right? And this axis is not perpendicular to this face. All these things are the problem. By looking at this, I can tell this parts cannot be used for an assembly. I have to reject it. But please remember, it is not the fault of the vendor. It is the fault of the drawing design engineer. He never said this face should be flat, or this place should be flat, or this axis should be perpendicular or concentric with this. This bore should be concentric with this bore. All these things are not specified. Hence, it is not the fault of the vendor. It is the fault of the design engineer. Design engineer is not specified. He knows that this face should be flat, but it is not specified on the drawing. Hence, we cannot tell. Vendor understood as it is, and he has produced as per the dimension, but it is of no use now. Hence, we need to reject the part. How to solve this problem? As a design engineer, now we have to provide some more information on this drawing sheet, giving it this surface should be flat, this surface should be flat, it should be concentric, it should be perpendicular, many faces should be parallel. All this information should be provided. Then vendor will understand better. Let us write all these things like this. This face should be parallel, this should be perpendicular, this should be flat. All these things we'll write in English, since We can do this like this, but internationally this is not acceptable. One of the key requirement of the drawing is it should have minimal local languages. Any language drawing should be free from languages except for few things, right? Particularly as per the dimensions are concerned, the drawing should be language free, because there can be a misunderstanding possible due to the communication through this language, or understanding of the language itself may be a difficult task. Hence, language is not permitted on the drawing. Then what is the best way? To meet this demand, GD&T was developed, right? All this, whatever I said, it should be flat, it should be perpendicular, it should be parallel, it should be concentric. All these things we have identified many symbols for this, and through the symbol specify all those things on a drawing sheet. We can see here, we can see, right, the flat, this surface should be flat, right? This is the flatness symbol. We'll be able to see this entire surface should be flat. These are the position tolerances. Position of this axis should be within 0.3. It should be parallel with respect to A. What is parallel? This surface should be parallel with respect to this surface. This should be parallel with respect to this. Whatever was the requirement identified, we try to put it using the GD&T internationally accepted symbols. This is why, to tell this, to control the form, control the orientation, control the location, control the runout, we require GD&T tolerances. Let us, I said in the beginning that drawing was given to the vendor and he has quoted, let us say, about $500 or something. Now, let us say I changed, the design engineer understood the requirement. Now all these requirements are put in the form of a GD&T, and let us say this drawing is given to the vendor. Now what will be the immediate reactions of the vendor? He says too many controls are there on the drawing sheet. Now I have to give the new quotation. Quotation may be, let us see, just a figure, it may be $1,000, because too many, he sees too many controls on the drawing sheet. Indirectly, what he is telling, GD&T increase the cost of manufacturing. This is a myth today. It is there in an industry. They think that too many GD&T, if you bring in, it will, what is called control will be, so I have machining or processing is really difficult. It's a myth in an industry today. GD&T will not increase the many cases. In a majority of the cases, GD&T will not increase the cost of manufacturing. In fact, it brings down the cost of manufacturing. It's a myth in an industry today. I think if you understand GD&T completely, if you understand how to interpret the GD&T completely, you understand why I'm making this statement. Hence, interpretations of all the, when something is said like this, GD&T information on the drawing sheet, you should be able to interpret it correctly, so that you'll understand it is tolerance of the position is not 0.3, it is much more than 0.3, much more than that. That we think that it is 0.3, it is not 0.3, it is much more than the 0.3. For that, we should have what is called as the interpretation of a GD&T language.